Hello and welcome to the second part of our series on how to set up a VPS for our side projects and applications. In this part, we will host our first application using Docker. And in the end of this post, you will be able to access the web application that you want to host under the IP of your server. In the next part, we will then connect that to a domain. So let's get started. The first thing that we will need is to install Docker on our server. For that, we have on the left side the command line for our server, and we will start by connecting to it. On the right side, we will then place the installation instructions for Docker or provided by Docker, and I will run it using those because it will save a lot of time and they are pretty well written. We accept this and then we copy the GPG key onto our machine, set up the repository as explained here, run apt-get update, and then install the Docker engine, containerd, and Docker Compose. Docker Compose will be pretty important in this part, so definitely don't forget about that. And after the installation is finished, we will have Docker installed on our system. And then we have to do two more steps to make it a little bit more convenient to use. So let's wait a little bit longer. Okay, one or more of the files have been locally. Yes, we want to do this. Okay, we clear our console and now we first add our current user to the Docker group. And when this is done, we have to refresh the group by running new group Docker. And now we should be able to run the Docker command without having to run it behind sudo. Then one thing that is only relevant for hosting a VPS is that we need to remove Apache 2 because we will not need it anymore and it is installed by default. Okay. As a short recap, we now have Docker installed, we removed Apache, and in the next step, we will create a little test application and host that on our server. So for the next part, we will create a simple repository with a simple web application. In this case, basically the Vite template with Svelte. It's a simple Svelte counter. And we just run the create Vite CLI for Svelte. And after it finished, we can enter the directory, install the necessary packages, and then run a dev instance. After the packages are installed, we can run the dev instance with npm run dev. Then we will get here a little URL that we can open in the browser, and then we see the application itself. It's nothing special, but a simple application that we can host on our server in the next steps. So now we will open this application in Visual Studio Code or any other editor that you want. And we will create a Dockerfile. A Dockerfile is basically a template for an image, and the image then is the template for a Docker container, and we will run multiple Docker containers on our system to host the application. So let's create the Dockerfile by creating a new file and calling it Dockerfile. And then we enter the following data. The first step is basically building the application. We specify a working directory, copy the contents inside, install the packages, copy the rest. This is necessary to provide appropriate caching, but don't worry about it. Then you can run the build step, and then in the next step, basically the final image, we'll use nginx as the base image and then copy the output from npm run build onto that container. And then we expose port 80, that will be important in a later step, and yeah, run nginx, and then it should be hosted. Then the next step is to create a new Git repository. We will do this with git init, and then we add all of the stuff to the repository as an initial commit. And then, yeah, we need to create a GitHub repository for it. To create a new GitHub repository, we will go onto GitHub and click the button to create a new repository, and we will call this Svelte counter. Then we set this to private and create the repository. Then we get here some steps that we can run if we have a repository set up already. So we just copy and paste them in here. And then we have these already pushed here. In the next step, we will create a new Docker image and store it inside the GitHub container registry. But to access the container registry, we first need to create a personal access token. For that, we click on our profile, go to settings, go to developer settings, click on personal access tokens, and generate a new token classic, and we will call it Svelte counter, and then write and delete packages as our access rights, and then we just generate the token. We then copy the value. Don't worry, I will delete it afterwards. You should never share this token. Now that we created the personal access token, we need to export it as a local variable with the command cr export cr path is equal to, we paste the personal access token, and then we have to log in using that personal access token. Therefore, we first print it into this command with the password stdin flag. And we basically just log into the container registry with the user Programmonauts. That's me. And when that is done, we get the login succeeded message, and then we can build our build the Docker file and call it Svelte counter latest, and then push it to the container registry. So in the first step, we build it. When it's finished building, we will do the push. Here you can see how it's running through the steps inside the Docker file. At the moment, we are, for example, at the npm install step, and then the next one will be to run the build. And then, yeah, we push the finished image to the registry. And now everyone, also our server, can access it. But to access it, we have to basically run these two commands again. So we have to export the personal access token, and then we have to use it to log into our server. Yes, okay, we can set that up if we want, but for now this will work so that we can pull the image. Always running Docker build and Docker push to bring our new image to our server is a little bit annoying. So we will create a GitHub action to automate this process. Action basically always runs when you push something, for example, to the main branch, and then it triggers the commands you want to do. For that, we will now create a new file inside the .github directory inside workflows, and we call it Docker publish. Into this file, we will copy the following content, and we will go through it step by step. As a small disclaimer, I also have this video as a blog post where you can easily copy all of the inputs that I'm running through here. Okay, so we will create a new action called publish, and it always runs on a push to the main branch. We have some environment variables. We push it to the GitHub registry, and the image name is Programmonaut Svelte Counter. We have the following job. It's called publish with the name publish image. That's what then is shown inside GitHub. We run it on Ubuntu as well, and it has the following steps. Login to log into our container registry, and then build and publish the backend. But before we can push this, we need to adjust our repository a little bit. We go to the Svelte counter, we go to settings, and we need to set some secrets. The first secret, or basically the only secret that we have, is the PAT, so the personal access token that we retrieved before and that's needed to log into the registry. So we just put it in here, say add secret, then add the new file, push it, and hopefully see, commit. Push it, and then hopefully see how a new action is triggered. And here we see the publish image step. It starts the job, and then it runs through the different step. After it's logged in, it builds the image, and yeah, exactly what we wanted. So next up, we want to host our container on our server. For that, we will use Docker Compose. Docker Compose is basically a YAML file where we specify the properties of our container, and that way we can just run the file and not have to always use a Docker run command, and it's way easier to work with that, in my opinion. So let's start by creating a new folder called Svelte Counter. We enter this directory and we create a new file, docker compose.yaml. And inside here, we specify the following container. Front end has the name front end. It uses the image that we are pushing all the time. And it has a port mapping from the internal container port 80 to the port 80 of the machine. That way, the web application is basically reachable under the IP of the server, but we will see that in shortly. So let's save and then run docker compose up -d. Now we have the server created, not the server, the container created and started, and we can access it under the IP, as you can see here. And we can do what we also want to automate this process. So every time we push a new image, we also want to pull the new image on our server and then restart the container. For that, we have to create an SSH key on our server and give that to GitHub as an input variable. So as also in the last part, we use the SSH keygen utility and generate a new public private SR key. And we do this on the server. The last time we did not do it on the server. Now we copy the content of the file of the private key. So of /home/max .ssh id rsr. We basically copy the contents of the file to our clipboard, and then we will use it in the next step. In addition, we also will add the public key. So id rsr.pub to the authorized keys of our server. So now that is done, we go back to GitHub, back to the secret settings, and we need to specify some more. The first one is, as already mentioned, the SSH private key. You should never share this one with other people, otherwise they can access the server, your server. The next one is the SSH user. In my case, that's Max. Then we also need to specify the host. So the IP of our server, that was this one, add as a secret. And then we also need to specify the working directory of our server. And the working directory is the directory containing the Docker Compose file. So in our case, svelte counter, and we will use the absolute path. Okay, that's secret. Now we added all of the secrets. Now we have to modify our GitHub action, and therefore we will create another job. After publish, we will also create a job called deploy. That job depends on publish to be finished, and then installs the SSH keys so that it's able to log in, connects, enters the working directory, pulls the new image and rebuilds the container, and then leaves the server and cleans up the SSH keys. So we have the same fun again. We create a commit that we then push onto our repository. And if everything worked correctly, we will now see another action executed with the feature deploy. And we can already see we now have two steps. The first step, publish image, And the second step, deploy image. Okay, you can see here that the publish image step worked, but the deploy image step didn't work. We have here in the install SSH key the problem that connection closed by remote host. That is something that happens with hosting us VPS. I don't know why. You have to just restart the server after the first installation one time. I forgot it this time around. So after the reboot of the server finished, you can log in again, and yeah, it's working now. But the problem that we had was that the GitHub action didn't work properly. So we will rerun the failed job inside the UI and see if it is working now. The problem was inside the SSH keys step, and that was the first one. And as we see now, it works. So that's just a little thing of of the hosting as servers with other servers. I'm not sure if it also occurs. Okay, but now we also automated the step of connecting and pulling the new version and then updating the container that is seen here. We recreate it and then start it again. As a little recap, we now have our server. We have Docker installed on the server. We have run our first container with the Svelte counter example application. And inside our repository, we created a pipeline that automatically builds an image of our application and connects to our server and updates the application. In the next video, we will now personalize this a little bit and give our application a domain and secure it with SSL or HTTPS. So thank you for your attention and see you in the next one.